Hi everyone, hi 12 bar students, this is Miss Long here. So first of all, Merry Christmas everyone. I hope you enjoy your break and promise me don't do a lot of study, okay? Relax and take some break. Well, as promised, I'm going to discuss a few questions from the exercise 8C. So I'm going to focus on question 3 and also question 9, I think. You probably noticed from 8C's practice a lot of questions that to do with the powers of the negative numbers or fractional numbers, okay? So let's have a look in details. Okay, let's look at question 3. So question 3 say consider the binomial expansion of this, and then write down the first four terms. So we see that the expression looks like this. It doesn't look like a plus bx to the power of n, right? So we need to rearrange it to that particular form. So let's do it. I'm going to write it on the side for 3a. Let's copy it down. So every time when we see the third form, we know it is to a negative power, right? So let's do it and change it to the power form. So it becomes 4 minus x to the power of negative 1 on 2, right? So negative half. And what else can we do? If we go back to the formula, we know that we need to pull out the a, right? We need to pull out the a. So in this particular bracket, we know that our a is 4 and our b is negative 1 in front of x. So let's take out the a, in this case 4. So take out the 4, and the rest of the bracket will become 1 minus x on 4, and then bracket to the power of negative half. And simplify a little bit, so 4 to the power of negative half, and then the bracket to the power of negative half. And the first section will just becomes 1 on 2, and the rest of it, let me just copy it down first. Now, we can use the formula to expand it. So in this case, we can use the sigma sign first. So 1 on 2, and then sigma from r equal to 0 to infinity. We have nr, n choose r. So n in this case is negative half, and r is just r. And then bx over a, remember the negative sign. So negative x over 4 to the power of r. Okay, and keep expanding. So this becomes half times the sum of from r equal to 0, so negative half, choose 0 times x over negative 4 to the power of 0 plus the rest of it, negative 4 to the power of 1, all the way to what? All the way to the fourth term. The fourth term, when x is actually equal to 3. Remember, the fourth term, r should be 1 less, right? So let's continue. So negative half, 2, and then x over negative 4 to the power of 2 plus negative half, 3, and then x over negative 4 to the power of 3 plus etc. And then brackets. Okay, let's simplify a little bit of the things in the bracket. So 1 plus, if you're familiar with the expansion, you can skip some steps in your head, but make sure to avoid any careless mistakes like calculation mistake or missing any numbers or copy it around somewhere, okay? Those are very common mistakes. If you want to avoid those, write it step by step and check the numbers. Okay, so remember that we've mentioned before, when you see n choose 0 is always 1, and n choose 1 is always n. Okay, so this becomes, the second part becomes negative half times to the power of 1, so it's the same. And then plus, okay, this section, remember we can use our formula now. So if you check your formula, it's over here. So n, for numerator, n times it all the way to n minus r plus 1, and then divide by r factorial. So if you have a look, the third part, which is this one, the r is equal to 2. So n minus r plus 1 is equal to negative half plus 2, minus 2 plus 1, and it should equal to negative 5 on 2 plus 1. So it's negative 3 on 2, right? Negative 3 on 2. So we should times it all the way to this number. So n is negative half, and then n minus 1 is also negative 3 on 2. So we should just stop here. And then 2 divided by r factorial, so 2 factorial. And then we continue plus the next term, which is the same idea using the formula. So it should be this, and then divide by this times 3 factorial. Oh, oops, I forgot to times this section to the previous one. So I should put it somewhere. Okay, over here. See, it's very easy to miss some parts, right? So make sure we always double check the numbers, the steps in front. Okay, and if we keep simplifying the bracket, it will become 1 plus 1 on 8x plus, let's use the calculator. So from your calculator, you should have 3 on 128 times x to the power 2, and then plus the 5 on 1024 x cubed. So please check it in your calculator. You got the same one, and let's simplify further. So 1 on 2 plus 1 over 16x plus 3 on 256 x to the power 2, and plus 5 2048 x to the power 3, and that's it. Okay, 3b. 3b, they want us to find the interval of convergence for this complete expansion from 3a. So what we can do is, because from our notes we know we need to find the bx over a in our original form. So if we can go back to 3a and try to find the form of the one I highlighted in red, which is over here, right? And in this case, we know that the bx over a is just this section. I'm gonna try to point it out again in this darker red, including the negative sign, right? Because in the formula, this is a plus sign. So you need to include the negative sign. So negative x over 4 is our bx over a. So let the absolute value of that be smaller than 1. So let me write it down. So now it's 3b. We should let the modulus negative x over 4 smaller than 1. So if we simplify that, we should get x over 4 smaller than 1 or larger than negative 1. So x should be smaller than 4 and larger than negative 4. So that's 3b. And 3c, let's have a look of what is 3c. Use the expansion to estimate 1 over third, the square root of 3.6. Check your answer by direct calculation. So you can use your calculator to check your answer, right? However, they want you to use the expansion to estimate it first. So we want to use the result from our 3a, right? So what is the result of our 3a? Let me zoom out a little bit. So it's over here. You can see it's over here, right? That's our result. And what is x in this case then? Let's have a look. So the original expression, if you have a look, it's over here, right? The original expression is over here. And they want us to estimate this. So in this case, 3.6 is just equal to 4 minus 0.4, right? So our x in this case is just 0.4. So we can easily just let, for 3c, we can easily just let x equal to 0.4 and substitute it back into our result from 3a. So if we substitute it in, we should get half plus 1 on 16 times 0.4, and then plus 3 over 256, 0.4 to the power 2, and then plus 5 over 2, or 1048 times 0.4 cubed. Okay, and so on. So because it's estimation, so we can put it into our calculator and rounded, you should get a result of around 0.527. And you can also use your calculator because they ask you to check the answer by your calculator too. So you can use your GDC, and then if you plug it in, you should also get a result of the same. Okay, so that's it. Thank you, everyone. Question now, you can see I put up the this notes that we've done it before in 8C. And here's the question 9. So let's focus on 9A first. They want you to write this fraction as the form of that plus that, where a and b are constants. So this should be very familiar to you, right? You have learned it in chapter 6, so the previous one, 6E, it's called partial fraction. If you forgot how to do that, you can go back and review this, okay? Otherwise, let's have a look. So basically the first step for partial fraction, we need to factorize the denominator, right? But if you look at the question, they've already done that first step for you. So we can continue to multiply both sides by the denominator to make them the same denominator. So what I mean by that, let's write it down. We can just keep the left-hand side the same. And then what we can do is we can basically make them the same denominator, and your numerator becomes a times x minus 2 plus b times x plus 1, okay? And then once we've done that, we can either equate the coefficients for your numerators on both sides, or a quicker way to do that, I think most of you did that in the unit test, is just let the x equal to the zeros of the denominator. So what I mean by that, let's lay out the numerators on both sides first. So x minus 8 should equal to the numerator on the right here, right? And then we basically can substitute the zeros of the denominators. So let's let x equal to 2 first, so that we're left with b for this equation. So your equation becomes 2 minus 8 on the left, and then a times 2 minus 2, just 0, and then b times 2 plus 1. Okay, so it becomes -6, 3b, and then b should equal to -2. Okay, and then same thing, we can let x equal to -1. So we can let the x plus 1 become 0, right? And we're left with a in the equation. So -1 minus 8 on the left, and then a times -1 minus 2 on the right. So -9 equal to a times -3. So your a is just equal to 3. Okay, and to answer the question A, we just need to tidy everything up and put them in that form they required, right? So let's write it in a form as the question asked. So 3 on x plus 1 plus -2 on x minus 2. Done. Okay. Let me just copy and paste our result from 9A. So that's the one. Let me edit it. So wait, how do I copy? And then now let's look at 9b. Hence writes an expansion for this up to the term x cubed. So in order to do this, we need to use our binomial theorem formula, right? So which is in our notes above. So for this formula, we probably see that we need to first find our a plus bx to the power of n form. We need to have this form, and then we need to basically pull out the a. So I think I demonstrated this already in class, but I will do it again. So what I mean by pull out the a is just, let me write it again. So a plus bx to the power of n, we pull out the a first. So a is taken out, and the rest will become 1 plus bx over a, bracket, bracket, to the power of n. Okay, and then if we simplify it, it will become a to the power of n, and then 1 plus bx on a to the power of n. And then if you expand it out, it will become the one written here using the sigma sign. Okay, so how do we approach this? Let's have a look. If we go back to the question, we know this is 9b now. So often with questions of those like sub-questions, we know each later one will build upon the previous one. So 9b will build on 9a. So if we have our 9a results copied here, then let's start from 9b now. So we know the expression already become this, but we just need to kind of like rearrange it to make it in the form of the a plus bx to the power of n form, right? So how do we do that? Let's have a look. Everything on the left won't change. And how about on the right hand side? So the first part will become 3 times x plus 1 to the power of -1 plus -2 times x minus 2 to the power of -1. So it's a negative power. Okay, continue. So let's change it to a plus bx form. So we move the x, we swap 1 and x, so it becomes 1 plus x to the power of -1, just to make it more clear. And this one becomes -2 plus x to the power of -1. Okay. Now we need to tidy things up, so nothing we need to change for the first section. However, for the second section, we know that our a this time, a plus bx, our a is -2, right? So -2, we need to basically take out the -2 outside of the bracket. Now, how do we do that? We take out the -2, and what we left with is 1 plus x over -2, and then bracket to the power of -1. So if we simplify this further, it will become -2 times -2 to the power of -1, and then 1 plus x over -2 to the power of -1 by index law. So this section will become just 1, right? So 1 times the rest of it is just the rest of it. So we copy it down like this. Now by now it is basically in the form of 1 plus bx over a to the power of n form, right? So then we can use our formula. Let's look at our formula again and see if we can expand it. So if we're going to expand the first section, I'm going to change the color. I'm going to use yellow now. The first section of this one, if we expand that, it will become, let's say, so let's put the 3 outside, and the rest of it, if we're using formula, the rest of it is just the sum of r equal to 0 from r equal to 0 to infinity, and then the nr. So n in this case is -1, and then r is just r. And what is bx over a? Bx over a in this case is just the x here, right? It's just the x here. So then we just put x and then to the power of r. Okay, so this is the first section if I'm using the formula. And then the second part, let me change to let me think, green color. Let's change to green. So the second section, this part will become what? This part will become, by using formula, we know the first section, where's the laser? Okay, the first section, a to the power n, a is just 1, right? So 1 to the power n is always 1, and then the rest of it, let's do the rest of it. So that is sigma from r equal to 0 to infinity, and then nr, so n choose r, n is -1, r is just r, and bx over a is just x over -2 in this case, so to the power of r. Okay, once you've written down this, let's continue. So by now, you're just using formula, right? Let's use formula to continue expand it. Please do it step by step for now, because you just want to practice more and get familiar with the formula. When you get more familiarized with the formula, you can skip steps in your mind, okay? So now we don't skip steps. 3 times, let's put a bracket on. And now when we use the formula, you can have a look. N choose R will just become what? If you go back to the formula, N choose R, we'll just use this formula over here, right? And substitute the R in. So the first one will become, the first one is N0, right? N0. So N is -1, R equal to 0. So -1, 0. And then x to the power of R. R is 0 in this case. And we're going to continue. -1, R equal to 1. X to the power of 1 plus -1, R equal to 2. X to the power of 2. And when to stop? From the question, we know we need to stop up to the term in x to the power of 3, right? So that means we can stop to the term when x to the power of 3. So we're going to stop here when r equals to 3. We know there's infinity of the terms going on. but we're going to stop here. Okay, same thing for the green part. Let's expand it. So this time, we have -1 from r equal to 0, and then x over -2 to the power of 0 first, plus -1, 1, x over -2 to the power of 1, -1, 2, x over -3, oh sorry, -2 to the power of 2, and then plus -1, 3, x over -2 to the power of 3. And we're going to stop here too. Okay, like this. And then if we substitute that into our formula, what will we get? Into our formula of this, I circle in yellow. So nr equal to n times n minus 1 all the way to n minus r plus 1 brackets divided by r factorial. So if we're using this, let's see. So the yellow section will become 3 times brackets, and -1, 0 is always 1, right? And 0 is always 1, if you remember. I've mentioned it before. I'll write it here. So n choose 0 is always 1. And how about n choose 1? It's always what? It's always n. Okay? So this one, make your calculation quicker. So continue that. -1, 0 becomes 1. So 1 plus the second part, -1, 1 is just always, n1 is just always n, then n is -1, so we just copy it down, -1 times x plus -1, 2 becomes what? If we're using formula, let's substitute it in. So the denominator is r factorial, r is 2, so 2 factorial, and then what's on top? Using n, which is -1, times what? Times n minus 1, which is -1 minus 1, which give you -2. And then continue all the way up to n minus r plus 1, which in this case is -1 minus what? Minus 1, and then plus, oh sorry, minus 2, and then plus 1, which is also -2. So basically, you want to stop at -2. So -1 times -2, that's it, and divide by 2 factorial. Okay, and then the same thing for the next one. So you can do it by yourself. Just do it quickly here. So the next one becomes, oops, this one I need to times x to the power 2. So don't forget that. So -1 choose 3 becomes -1 times -2 times -3 and divide by 3 factorial and x to the power 3. Okay, and the same thing for the green section. I'll just do it quickly here. -1 times, and then plus -1 times -2, 2 factorial, x divided by -2 to the power 2, and then plus -2, -3, 3 factorial, x over -2, power 3, plus the dot, and then brackets. Okay. So once you've done the expansion, what we can do is just simplify a little bit, right? We just simplify a little bit. So the yellow section will become 3 times 1 minus x plus x to the power 2, and then minus x to the power 3, and so on. And the green section, if you simplify it, it will just become 1, and then plus x, 1 plus x on 2, so half times x, and then plus 1 on 4, right? 1 on 4, and then x to the power 2, and then plus 1 on 8, x to the power 3, and so on and so forth. Okay, and keep simplifying. We basically times 3 for each term, right? Inside. So the first section just becomes 3 minus 3x plus 3x squared minus 3x cubed and this green section doesn't change. And if you're gonna just add them up and group the like terms together, it will just become 4 minus 5 on 2x plus 13 on 4x squared and minus 23 on 8x cubed. So that should be your final answer for question 9b. Okay, if there's no calculation error, that'd be great. Good luck. Now 9c, for what values of x does the complete expansion of this converge? So we want to find interval of convergence. If we go back to our formula, when we have the formula of this form, our bx over a modulus will be smaller than 1, right? Within that particular interval. So where from 9b we have this particular form, let's find it. So it should be in this step where I've highlighted in red, right? So this step we can see we have 1 plus x in the bracket and 1 plus x over negative 2 in the bracket. So we can easily see for the yellow section, let me just find my yellow pen. For the yellow section, what is bx over a? It's just x, right? So x, absolute value of x should be smaller than 1. And for our green part, we can see x over negative 2 is our bx over a, right? So absolute value of that should be smaller than 1. So if we simplify, the yellow one is just x larger than negative 1, smaller than 1. And the green one is just x larger than negative 2, smaller than 2. So if we need to meet both conditions, then overall, we need to have x larger than negative 1 and smaller than 1 as our answer for question 9c to make it converge, right? Okay. Finally, 9d, use your expansion to estimate the value of this when x equal to 0.05. How do we approach this? We can just substitute it back into our expression found in 9b, right? So we know x, we know the expansion result, so we just substitute it back in to solve it. Very straightforward. So 9d, when x equal to 0.05, we just substitute it back into this. Then what we should have for this is just 4 minus 5 on 2 times 0.05 plus 13 over 4, 0.05 to the power of 2, and then minus 3 over 8, 0.05 to the power of 3, and so on. If we put into the calculator, we should get the result. It should be approximate sign. So equal to 3 point. Did they say rounded to? They didn't. So maybe rounded to 2 decimal places, 3.88. Okay, thank you everyone.